So previously we talked about how objects will not move or will not stop moving unless they're acted on by a non-zero net force. So now we need to actually define what we mean by a force. So jumping into this, a force is a push or pull. Let me actually be more precise and actually write push or pull there for you. So it's a push or pull interaction between exactly two objects. So it's always between exactly two objects. So if it's three objects, it's not a force. If it's not a push or a pull, it's not a force. So some examples here are the gravitational pull on you by the Earth. So the Earth pulling down on you using the gravitational force, that's a force. Push of your hand on a basketball. So if you push a basketball, you are exerting a force on it. Or the pull of a rope on a hanging light. So if you've got like a lamp or a light hanging in your ceiling, a hanging light, there's a force that's pulling up on that light from the rope. The variable that we use for force is a capital F, and then what you'll often see is a capital F with like a lowercase g for gravitational force, or an N for a normal force, or friction for FR for friction. So these are subscripts, just in case that's not clear, so they should be tiny little letters next to it. It's not just a lowercase, it's actually like small and below there. I'll take a look at your work and let you know if you need to adjust that. And then the units are a Newton, which we simplify as a capital N. This is also, we'll learn later why, but this is also equal to a kilogram meter per second squared. So 1 kilogram meter per second squared equals 1 Newton. So again, a force is a push or pull interaction between exactly two objects. Whoops, I went backwards. So when we talk about forces, there's actually 4 fundamental forces in the universe. So everything that happens is because of one of these forces. That's our current model. So the gravitational force is the pull force between objects with mass or energy. The electromagnetic force is the push or pull force between objects with electrical charge. The weak nuclear force is responsible for neutrons decaying into protons. And the strong nuclear force is the pull between touching protons and neutrons. So you don't really need to know these at this point. The only one that's really going to come up this semester is gravitational force. Next semester, we'll talk about electromagnetic force, and then very briefly on these last two. But these are the 4 fundamental forces. They're the only forces that kind of in our model, the only ones that technically exist. The rest are just approximations I'll talk about in a minute. So you don't really need to understand these, but if you have questions or want to learn more about them, check in with me in class. I just wanted to point this out here so that we know and you've been exposed to it. Most of the forces we're going to talk about in this unit are known as composite forces. And so these are composite forces. And a composite force is basically, you have a bunch of electrons and protons and stuff, say, in your hand, right? You've got all these atoms in your hand. And then if you've got a ball, there's all these atoms in that ball. And then how these two interact, how the atoms in your hand interact with the atoms in the ball through the electromagnetic force, that would be a lot of math to talk about every single atom and how they all interact. So instead we talk about the composite effect, meaning combine it all together and what do you get? So a normal composite force is a contact force perpendicular to the contact. Or in other words, you can think about this as most push forces. So if I push on the wall, that's a normal force. If I'm standing on the ground and the ground is pushing me up to counteract the gravitational force, that's a normal force. Basically, anytime something gets pushed, it's probably a normal force unless it's the electromagnetic force. Tension is a pull force due to a rope, string, etc. And this is going to be pretty self-explanatory. This is most of our pull forces. So if I'm pulling on a rope, then I'm feeling tension from the rope. If a rope is pulling on something, it's feeling tension. If you've got a spring that is stretching, that's going to have tension force in it. Then lastly, you've got friction, which is a contact force that is parallel to the contact surface and opposes motion. So you're familiar with this probably. It's what keeps, like if you're sliding along something, it's what slows you down. It's always opposing motion and it's always pointed parallel to where the two things are touching, as opposed to the normal force, which is pointed perpendicular to where the two things are touching. So that's the basics of forces that we're going to talk about in this unit. We'll get into more detail in our next unit.